Greetings, ladies and gents. Welcome back. It's Mike Maths and Science Club. Today we are looking at the double angle identities. So on our last sessions that we had, we looked at the combined angle identities for cos and also for sine. So in this video, we are going to to prove, of course, the combined the double angles in this case for cos and also for sine. So we have, of course, the double angle for sine and also for cos. So the way this proof goes now, if you remember on our last, of course, session that we had on the practice section for the combined angle identities, we kind of did something that was similar, of course, to that there, but instead of theta in this case, it was a. Now the way this proof goes is that we prove it we prove it using the compound angle identities, by the way. So what we are going to do, instead of writing 2 theta, we know that 2 theta in this case can be rewritten as theta plus theta. So we know that, of course, 2 theta in this case, 2 theta can be written as theta plus theta, right? That's how we we were doing those identities, of course, on our last section, of course, on the application. So that's what we are going to do here. So what we are going to do is that we are going to rewrite that 2 theta as theta plus theta. So in the actual fact, this will become, now if I change that 2 theta to theta plus theta, this will become cos of theta plus another theta. Now, if of course you can already notice from this point that this is actually a compound angle identity for cos. Now, what does it say? It says we cos the first angle, we cos the second, minus we sine the first and sine the second. So in actual fact, when you expand this, this will become cos of theta multiplied by cos again of theta. Remember, the second angle is still theta, right? That says minus, of course, if we subtract that, you would have sine, you'd have sine. So it says sine of theta multiplied by, of course, sine of theta again. So of course, if you simplify that, of course, we know that cos of theta multiplied by cos of theta, so that will give us that will give us cos squared of theta. So in this case, this would be cos squared of theta minus, of course, those two again. When you multiply them, they would give you sine squared of theta. So that's the first version for the cos identity, for the cos double angle identity, rather I should say. So there are 3 versions of it. So this would be the first version that we get. So the other version in this case, so if you remember from grade 11, we know that sine, of course, squared of theta plus cos squared of theta, that gives us a 1, right? We know that, of course, from grade 11. Now, if I were to rewrite, that expression there in terms of sine, in this case, I would have, of course, sine squared of theta, that would be equals to a 1 minus cos squared of theta, right? And if I were to rewrite that, of course, in terms of cos, of course, for the second time, this would become this would be cos squared of theta. It will become 1 minus sine squared of theta. So that's it. So that would be the expression that I get when I rewrite that in terms of course, is cos squared is the subject of the formula. Now it actually works the same way. Now remember, you can see that we have cos squared minus sine squared. Now of course, you can already see that instead of me rewriting that, writing that as cos squared minus sine squared theta, I can actually replace that sine squared as 1 minus cos squared. So that's what I'm going to do. So from this step, what I'm going to do is that I'm actually going to replace that sine squared theta with 1 minus cos squared theta. Of course, in this case, this will become cos squared of theta minus, now you must put it in bracket, of course. If you don't, it might cause some problems along the way. So of course, that will become 1 minus cos squared of theta. Now if you, of course, you simplify that, you would have a cos squared of theta minus 1. Remember that negative in that of course positive, it will give us 1, negative 1 rather, and also that negative, if we multiply that negative and that negative, that will give us a positive, so this will become positive cos squared of theta. And if I simplify that, of course those two are like terms, so I would have 2 cos squared of theta minus a 1. So this would be, so this is the first version. So this would be, of course, the second version when of course I replaced, of course, that sine squared with 1 minus cos. So this is the second version that you get within the cos double angle identity. And the third one would be from this step, from that step there. How about I just replace that cos squared of theta with in this case with 1 minus sine squared theta. So when I replace that cos squared, of course, with 1 minus, so this would become a 1 minus sine squared, of course, of theta. Of course, we still have that minus, right? So this would be minus again sine squared of theta. Now again, you can see those two are like terms. So in this case, I'm going to add them up. So if I do that, I would have 1 minus 2 sine squared of theta. So this is the third version of the cos double angle identity. Now let me just write that as a summary. So we're gonna have, we have cos squared of theta. Actually it's cos 2 theta rather. So that's 2 theta would be equals to, so we have the one that says cos squared, of course, of theta minus sine squared of theta. But also the other version, of course, it would be that second one which says we have cos, that would be cos, actually that would be 2 cos, so that would be 2 cos squared theta minus 1. And so this would be, of course, the second, and then the third one, in this case it would be 1 minus 2 sine squared of theta. Now these are given on your formula sheet. Of course, I think I've seen in one of the exam papers where they actually ask you to prove this. So I would suggest that you know it, because those are free marks of course for the proofs. So of course we also have the one for sine. Of course, these are the only, of course, 3 version for the cos identity, for the cos double angle identity in this case. But for sine, we're actually gonna do the same thing. We're gonna rewrite that 2 theta is theta plus theta. So if you do that, you would eventually have, of course, this would be sine of theta plus another theta. Now of course you can see that's actually a compound angle identity for sine. So this would be sine, of course, of theta multiplied by cos of theta plus it will become, of course, it is actually cos of theta multiplied by sine of theta. Now some of you can already notice that these two are like terms, even though it is written the other way around, of course, on that side. But we know that, of course, multiplication is commutative. So in this case, I'm just gonna rewrite that so it actually looks the same. So this is gonna become sine of theta multiplied by cos of theta plus, of course, I'm just gonna switch off that other way around. So it's gonna become sine theta multiplied by cos of theta. And you can already see now that these are in effect the same. So in this case, these are like terms. So this would give us 2 sine of theta multiplied by cos of theta. So this is the double angle identity for sine, so that we have in grade 12. So this would be sine of 2 theta in this case. So we have actually, so the sine double angle identity in this case, it doesn't have other version. It's not like this cos double angle identity, which is 3 versions. But this one, of course, it has only one. So that's what you need to do to note in actual fact. So what we are going to do is that we are going to do, you know, few questions to try, you know, to practice this idea of the double angle identities. So that's what we are going to do in the next video.